Okay, then electric field. Okay, what is electric field?
The region around the charge that where a charge or where any charge kept experiences the force by the other charge.
Yeah, force by other charge. Let it be attraction or repulsion, doesn't matter. So space around electric charge, where it exerts force. No, we can just relate this with the gravitational force also. It's also similar to gravitational force. If you know what is, if you remember what is gravitational force, tell me. Formula.
G into M1 M2 upon R square.
M2 upon R square. Electrostatic force F equals to K Q1 Q2 by R square. So electric field, we can say, is equals to force per unit charge. So force equals to K Q1 Q0 by R square into 1 by 2 naught. So it is K Q by R square. So what will be SI unit then? Electric field intensity.
Coulomb upon meter square.
Coulomb upon meter square.
Yep.
What about K?
K is a constant, right?
Yes, but it is also having some unit. Constant have unit, some values and unit. K equals to 9 into 10 to power 9. Last class we calculated. Because it is 1 by 4 pi epsilon naught. So epsilon naught value is 8.85 into 10 to power minus 12. So if we calculate this, we'll get 8.99 in 10 to power 9. So we round off to 8.9 10 to power means 9 10 to power 9. What about unit here? We can get unit from this formula. Newton per Coulomb. If you want unit for K, you can get from here. Cross multiply this two. That's it. Crashed. Second crashed. ठीक है. Is my screen visible?
Yes, sir.
So dimension for K, if we cross multiply here and divide by here, so K equals to Newton meter square by Coulomb square. Newton meter square by Coulomb square. That is what dimension of K. And if we go from here, same thing we'll get. This is Newton meter square per Coulomb square into Coulomb means Coulomb will get cancelled. Here denominator meter square. So meter square will get cancelled. So dimension of this Newton per Coulomb. Okay. Will you remember the unit?
Yes, sir.
Now, can you get me dimension? Quick. On dimension, very quick. What a dimension for this force? Dimension of force.
MLT minus 2.
MLT minus 2. Dimension of Coulomb, I mean charge.
AT.
AT. Very good. So AT and MLT minus 2. So combine this and tell me what will dimension of electric field?
MLT minus 3, A minus 1.
Very good. That's it. MLT minus 2 by AT. So MLT minus 3, A minus 1. That's the dimension of electric field. If you want to make a note, there's nothing much here. You can remember this all. Okay. Lines of force. So what are properties for this one? Before properties, what is electric lines? Electric field lines. You're studying 10th standard. Come on.
So can you repeat your question?
What are electric field lines?
The lines representing the electric field.
Yeah, those are imaginary line. We are imaginarily representing this electric field around some charge, wherever it is, which is drawn direction, which is drawn like something we are drawn tangent to it. So electric field lines around this one. Okay. So if we say properties, so from positive, it diverges outside negative, So it moves inward. There is converge, negative, converge, positive, diverge, diverge outside.
So,
Yeah,
I'm having some network issues. Can you please repeat what you just said?
yeah. I'm saying like we're just talking of properties. Like positive charge, force, it goes diverge outside, goes away
Okay.
from the positive charge. And in negative charge, it comes towards, or we can say converge. And this positive charge diverge. These are just, we are representing a line of forces, electric field lines of force.
Okay.
So by this, we can conclude here, it always moves from higher potential to lower potential. Okay. Like the simple, we can say like some electric field lines. If I draw here, it get diverged and it converge in a negative charge. So in short, we can say unlike charge, attract. Attract each other. And if we place some like charges, it will be repelling. And next one, we can say this many lines, how we are drawing 1, 2, 3. This represent like a charge is proportional to number of field lines. So that means number of lines represent by Q here, or this line. So we can say number of lines, let's say like that, originate from positive or terminate to the negative, whatever, positive and negative, terminate. They are proportional. Proportional to magnitude. And fourth one, of force never intersect. They never intersect. Now, suppose if they are intersecting, that means that will show two direction at the same point. If you remember, same reasons we had in 10th standard also. Like electric field lines never cross each other because at that direction there will be 2 point of direction. Suppose this is electric field lines. It's going this direction, and if it is crossing, so if I draw tangent here, one tangent will show this direction, one tangent will show this direction. So this is not possible. Both direction not possible at a point. It can change direction multiple times. That's not our problem. But at a point, there should be only one direction. There, you can say they here from here only will write originate from positive terminate at negative. So therefore, make closed loop. See, this electric field line do not make closed loop, but magnetic field lines makes closed loop. So that will study in magnetism. But so magnetic field lines, they make closed loop. North to south and inside, back to north. But electric field line doesn't. It just originates from north, I mean positive, and terminate at negative. They do not make closed loop here. So as much as now, as we are drawing here, even in magnets also we have studied, like when we are drawing here, so many field lines here cross magnetic field lines here. So at this point means poles, at poles, North Pole and South Pole, the strength is more, which is represented by its density. We are drawing so many lines from there. Same manner here also. As much as close together, the magnetic field lines so this one we can say strong and weak. So make a note of all this. Done?
Yes, sir.
Yes, sir.
चलो ठीक है. Everyone?
Yes, sir.
Very good. Now we can write here some 6 is this one, right? Then let's make it here 7. So in this one, electric field line of force generate or terminate at charges or surface at angles. That means if these are some negative charges and this is a positive charge, means it will attract some negative charges from here. Hear me, guys? Am I audible?
Yes, sir.
Yes, sir.
चलो ठीक है. My Wi-Fi got disconnected. Okay. I need to make it DND. Okay. चलो तो next. So we wrote before also charge distribution, area wise, length wise, volume wise. Yeah. various charge distribution. We wrote for first one, see, I'm not going to derive anything here. We'll just see formulas and how we are using formulas in your like a competitive exam. That's what we are going to see. Formulas and the shortcuts. Electric field due to. Okay, like one more thing. Keep tracking your formulas. Like I'm saying every time, like my old student knows. So keep one notebook, like notebook instance, not big notebook, one palm size notebook for your just for formulas. Ajay, are you maintaining?
Yes, sir.
Okay, what about Samhita?
I
I
should
see.
maintain it, sir.
Till which chapter have you maintained?
I did it in school. I have to do it for tuition too.
When I ask you to maintain one small notebook for that.
Yes, sir.
Okay, okay. Because this thing only will help you for your like final studies. Like right now, crash course are going on, right? I'm taking that. For that, like you cannot go everything and you can learn and no. That is a rubbish thing. If you study each and everything and no. Just see formula, what's the concept. So make one like how I'm writing your formulas and they're neat, okay. In your own words, like okay, where we will use this, some special notes or some special note here or some condition, something like that, whatever it is. If it has condition, then in like one small palm size notebook or a small like note diary formula, small handwriting, keep it like that. In one page, full chapter should be completed. All the formula should be there. So it will be very useful for your final studies. It will be same. E equals to K 2 by x square from 1 point plus Q point P is the distance x. Second, circular ring with formally point P here, radius R, Q plus charges, and here electric field. And distance x equals to A Q x by R square plus square 3 by 2. One second, like I just got a call.
Sir, you're on mute.
Yeah, a circular disc of radius r. Radius r with this was uniformly distributed charge. All this here it is surface. We'll just include same diagram. We'll include here surface also. You can draw same diagram here. We'll include this outer surface. What you can see here is border. Uniformly distributed charge with K Q by R square 1 minus x by R square plus x square. Diagram we can draw same. Same diagram we can draw here.
Sir, what is UDC again?
I'm sorry, what?
So what is UDC again?
Is uniformly distributed charge. Okay. Done writing? Okay, can you all turn on your camera so I can just see you're done or not? So I won't ask again. Turn on your camera. Quick. Vishil, okay, Bhanuri. Yes, turn on. Remaining two, come on. Okay. Infinite sheet of uniformly distributed charge with charge density. Some charge from here, any surface, any random surface. From here, we are taking a point P from where electric fields are passing. So there it will be sigma by 2 epsilon naught. So what are we writing here? Electric field due to some different charges. So first what we saw, due to an isolated point charge. Next we saw a ring which is uniformly distributed charge. Third we saw same some disk that was a ring. It is disk which was like uniformly distributed charge. A disk, it means that will be some area also. So we took surface area. Then some infinite sheet. So infinite sheet we are taking surface again because it's also area. In this ring we haven't taken area here because it's just a ring. If you know that ring, that it is just hollow in between. right? Ring is a shape as hollow cylinder. Okay. Same way, first linear charge density will write. A finite length of charge with linear charge density lambda. If you remember what was linear charge density? No idea? Charge per unit length. Surface charge density. Charge per
unit surface.
area, surface area. And there is one more. What was that?
Volume.
Yes. So, which will be charge per unit volume. Simple. Okay, so here we are taking one finite length of a charge with the linear charge density lambda. So this is some charge here at a point distance P. You can use your scale and whatever. In this direction. So Ex equals to K lambda x into sine alpha plus sine here beta for x direction, right? And this for y, it will be opposite. One direction up, one direction down. Okay. Ey equals to K lambda by x cos alpha minus cos beta. So in some case, alpha equals to beta, which is equals to pi by 2. When it is pi by 2, what you will get? What will be the Ex value? Can you tell me? What is sine pi by 2?
1,
1,
Cos pi by 2?
0.
0.
So Ey will be,
Ey will be 0.
and Ex will be
1.
1. Check again.
Ex will be K lambda by x.
2 K lambda by x,
Okay.
because there are 2 here. 1 plus 1.
So
Yes.
shouldn't there be cos theta along x-axis and sin theta along y?
See this angle this is angle with component here, as you're saying this side should be cos, right? This one should be cos and sine in y-axis. Sorry, x-axis. If I erase it again and draw. Actually, you're right. It should be here ex and this should be ey. This is falling on this side, so it is. I mean, you can say here. No. See, this angle it is making here. If I take this triangle here, I want in this direction. Okay. So if I take this vertical, I will convert this into vertical form. Okay. So this side, same. It will be same that here. Beta and alpha. So beta and alpha. Again, it will be cos component here. Yes. Again, it will be in x direction only. Yes, it is right. If I take here also, this will be beta and this will be alpha. If I take cos beta here and cos alpha here, and vertical will be same. Yes. So we can change here y and x. That's very good that you noticed. Good. Okay. So yeah, we have to change this one also then. Will be x. So ey equals to 2k lambda by x and ex equals to 0. Right? Now any problem here? Is it correct now? Yeah, I guess so. Okay. Shall we go next? Oh, it's time up. Chalo, theek hai. Still some more cases. So these are some cases we are seeing electric field due to some various charge distribution. Now this we will use directly as a formula. Okay, guys. See you next class.